this lesson, we are going to do the fundamental theorem of calculus, which is kind of a big thing. So the fundamental theorem of calculus is going to find us an area. It's going to find us an area under the curve of some sort of a function that's bounded from some value to another value. And so what we're going to do is when we do the integral, it means basically we're doing the antiderivative. And so when we do the antiderivative, it's going to create another equation. And then we're going to be plugging in the top bound into that equation, and we're going to subtract out the lower bound. Right, so let me show you how that works. So we've already done this problem in a previous thing, but we did kind of a geometry version of it where we graphed this line, and that line ended up creating a trapezoid, and so we ended up doing actually the equation formula for it. And then that allowed us to go ahead and plug in a value, or we could have just drawn the picture and found our area. So we know our answer is going to be 30, but let's do the calculus on it. So for us to do the calculus on this, we are going to do the integral from 2 to 5 of 2x plus 3 dx. All right, so that's us we're about to do the antiderivative. And so our antiderivative is going to be, we're going to add a power, divide by that power. So we're going to take 2x, we're going to add a power, divide by that power, plus 3x. And we're going to go from 2 to 5. Okay, so I still have my bounds. I still have some values that I need to plug into this. We just haven't got there. And so this simplifies out to x squared plus 3, then from 2 to 5. All right, so here's where the math kicks in. So this is now, we've done the antiderivative. Now we're going to plug into this new equation. So this equation represents the area equation from this value to this value. So we're going to plug in the 5. So we're going to do 5 squared plus 3 times 5 minus 2 squared plus 3 times 2. So we get 25 plus 15 and minus 4 plus 6. And so that's going to be 40 minus 10. And that equals our 30 that we got from this previous problem of actually drawing it all out and figuring it out. So I want to go back to this and talk about what's happening. Why does this work the way it does? And so if I draw this up, the values that I would need are the 2 and the 5. And I know that when I plug in 2, we got a value of 7. So we get 2 times 2 plus 3 equals 7. But I also want the 0. Excuse me. So if I plug in 0, I get a 0 plus 3, 3. So there's 1 point. And then 3, 4, 5, 6, 7. And then when we plug in 5, we would get 13. So 7, 8, 9, 10, 12, 13. All right, so I have this point. I have this point. Well, I plugged it on the y-axis. It was the 7, yes, but it's when our x value is 2. All right, so we have this linear equation. Okay, but we're finding the area from here to here. And so I want to talk about where these values come from. So this is our eventual goal of our area. But what the fundamental theorem of calculus does is when you are plugging in the 5, you are actually finding the area from 0 to 5. So if you do 0 to 5, and you plug in these heights and you actually do the area of this, so if we do 0 to 5, we would be plugging in, we'd have 1/2. The height would be from 0 to 5. And then the bases would be 3 plus 13, 3 plus 13. And so if I did all that math, I have 20 or 16. Half of that is 8 times 5 is 40. So not a coincidence that that's that value. So that value represents the area from 0 to 5, but that's too much. And so then we want to figure out what the area from 0 to 2 is. And so that would be a 1/2. This gap would be 2. And then our parallels would be a height of 3 and a height of 7. So 3 plus 7. So we're looking at 10. Half of 10 is 5 times the 2 is 10. So that area is 10. So the whole thing is 40. That area is 10, and that's what ends up happening. It's kind of the donut idea. You're finding the area of the whole shape, and you're subtracting out the area of the smaller to leave you with what's left. So we're finding the area of the whole thing. That's what plugging the 5 in is, that lower or the bigger bound. And then we subtract out the area from here down, which leaves us with the gap in between them. So that's us introducing the fundamental theorem of calculus and a little bit of why it works out the way it does and what's actually happening behind the scenes. Why are these values what they are? But at the end, you're going to find a larger value, subtract out a smaller value, and that's going to get the value in between.